Yeah, so today we're going to talk about data visualization. So this is, if you remember, this is section 6 of the module 1, which is like the new version of the curriculum. And just know that it's an important aspect. You guys are probably already doing data visualization, so I'm kind of thinking like it's an additional topic. And so one thing I'm going to do, since you guys have done data visualization, and the curriculum shows a little bit of code and stuff like that, I'm mostly going to talk about like what makes a good visualization and what you should be using. Note that most of these rules I'm going to say, I'm going to have a very strong opinion on a lot of these things. There's obviously, you know, some flex with every rule. You can break it. But in general, there are some pretty, like I would say most of the stuff I say, if not everything, is pretty much a good like go-to. You know, rules are meant to be broken for whatever reason, but other than being pie charts, which I'll say, don't use a pie chart right now. And I know I've already said this before, but we'll talk about why pie charts are just not great, okay? And I'll give evidence too. All right, but let's get right into it then. So let me go start sharing my screen. Which, there it is. Okay, and then of course, Zoom likes to make you guys disappear. I can't see you guys when you guys give a thumbs up or not. All right, so you guys can see my screen. Look, it's data, not very exciting. Okay, so this is all on GitHub too, on the repo. So I didn't mention this. I'll mention it real quickly. The repo kind of changed the structure to kind of reflect more topic-based for version 2. So just know this a little bit different if you have, if you need to pull from that, it's updated. Okay. So first thing, data, right? So reason why we do the data visualization, and it's kind of like, okay, like it's an aspect of it, but sometimes people I think kind of forget what it is. If you guys don't know How I Met Your Mother, this is one. How I Met Your Mother has these like weird parts where I'm just like, kind of gets me. One is that Marshall, one of the characters, talks about his favorite bar charts or bar graphs, describing his favorite pies, and his pie charts, describing his favorite bars. I just thought that was kind of funny because you can kind of represent data into different ways and what makes sense. I don't know. I always like to kind of put a little joke within like my own little data visualization. So like even if it's like a little internal one, like, it kind of makes me just laugh a little bit. So anyway, we have data, and so we should actually do something with it. And so visualizations actually really help us. So main part is like, why should we care about this data? Okay. Or like, why should we care about data visualization in general? Because like, if you think about it, like we have all the data, we can do the statistics, like the data visualization itself doesn't actually help you do predictive modeling or, you know, say like, oh, like, you know, is this statistically significant? Usually when we have a visualization, we usually have some kind of numerical part to back us up, right? So a lot of times, like, why should we really care? Well, a big part of it is basically, it's a story, it's a narrative. Like that's your goal as a data scientist. You're communicating these results. And so this can be like to a business stakeholder. So those people need a certain kind of visualization versus something like a data analyst or other data scientists. They have a different kind of need. So you might have a different kind of thing. And also note that you are part of this audience too. You're telling yourself a story. So when you're doing a data visualization, this can help guide you in what you should explore further, or kind of, you know, maybe give you, you know, say, I have a hunch about this. You do a quick visualization. You're like, oh, it does look really clear. It's like, oh, it is not quite what I expected. So you can help use these things to guide yourselves in. And just know that like, it is, I think it's a big portion of data science. It's kind of more focused on data analysts because data analysts tend to be more of the people who are going on the non-predictive modeling aspect. But I think it's an important part, not just to share, like to communicate to other stakeholders, but also to yourself to be able to understand how to do this. So a big part of it is a picture's worth 1,000 words. You've heard this a million times, right? It's a picture's worth 1,000 words. And that's because when I look at this, I can quickly look at this visual and I can very quickly say, oh, that blue bar, I don't even know what the numbers are or what's going on. It's like the blue bar is clearly bigger than the rest of the bars, and the rest of the bars are really small. Like that is just like us immediately looking through. I think we take a huge advantage of it. This is actually me emphasizing that the occipital lobe, if you guys, I don't know if anyone has biology, but occipital lobe, it's actually a pretty big portion of our brain compared to a lot of other senses. Obviously we have our frontal lobe, which we're not going to pull biology, but basically a lot of like decision-making skill. But occipital lobe, part of the visual cortex, basically is a huge portion of our brain. And so we actually dedicate a lot of brain processing power to visualization, or not visualization, seeing and visuals and stuff. And so we, like, I would say evolutionarily have kind of been designed to like look for patterns within visualizations and stuff. So anyway, it tends to be about like almost 20% of your brain. I think it's like 18% according to the source, is the occipital lobe. So it's a big portion. So that's kind of like me emphasizing why it really matters. Also, again, a little joking here, it's a visualization on why visualizations are important. So interesting to do. So the main thing, again, is like picture's worth 1,000 words, okay? Other part is that numbers are just bad to look at. No matter how good you are with math, humans are just not meant to perceive numbers abstractly, like in a large part. We can use numbers to compare and stuff and help guide us, basically extend what past or like evolutionary like understanding are. But numbers are really helping, like numbers just aren't useful to look at. So kind of show this emphasis, right? Is that I have a little data set here, right? And if I look at this, I display this data set, and you look at this numbers, right? What can you tell me about these numbers? And kind of, I mean, you could tell me about them. You could maybe calculate the mean, you could calculate the standard deviation, you could calculate all these different aspects, but like, it's not super clear exactly, like, I don't know, looking at it, at least for me, I'm not like, oh, I recognize what this pattern is. Like just looking at these numbers, I can order and try to help myself, but the numbers themselves don't really help. And so if you actually look at this data set and you actually plot it out, you'll actually see that it's very close to a linear line. Oops. There we go. You can see like it's got that pattern right here, but it's a little bit of randomness. And like that's something different. Like I can show you this plot and you can immediately get information from it compared to just looking at numbers. And this is only 10 numbers. So you can see like how quickly that has changed. Okay. So here's another distribution. And so look at this number. Okay. So does anyone have any insights on this part? Probably not, right? First thing you might say, are you trying to trick me, Victor? Are those the same numbers? Or like how far off are those, right? And I don't know about you, but like when I look at this, I can see there's a little difference. Like clearly like that 10, like because it's the first one is different by 1. That means nothing to me, but like it's different. And I can do comparisons like, oh, look, there's kind of some little difference. I don't really know, right? But in general, you can't really tell quickly and easily what that is. I mean, maybe if I ordered it, it'd help a little bit, but in general, it's just like, it still needs a little more processing for me to understand. So it turns out though, this visual looks like this kind of data, okay? Beautiful, right? Okay, and so what's really interesting about these two, and the reason why I put these specific data sets is that what's interesting is if I actually do, let's see if I can do this really quickly. I always hate doing live coding, but let's see if I can do this really quick. Okay, so we can actually see like, here's the mean, and this one also, also the mean. You can see here the averages, even though they look very different, are the same. In fact, if I do, let's say, the variance, okay, the variance is also the same. And you're like, huh, really interesting, right? And let's see, what other things could we do? Mean, median, oh, median, right? Median, They're the same again, but clearly they're very different. And this is for the important part. This is actually part of, I'm gonna butcher his name, is Askaobn. It's spelled Askaobn, quartet. I hope I spelled that right. Let's do a quick Google search because I wanna make sure if you guys ever find it again. Yes, Askaobn's quartet. Basically, it's a set of data, and you can see here, is that he found basically 4 different sets of data that have essentially almost all the same stuff, including the correlation factor R, right? And basically you can have essentially the same lecture line, but you can clearly look at these different data sets and they're very different from each other. And really the best way to do this is literally just visualization. Like if you try doing any, not inferential, but descriptive statistic, it's not going to come out something meaningful to you. And so there's a last one here. What if we had more numbers? So this one actually you'll see, like I'm not even gonna say like, what is this? But you can see like about 142 data points, right? You see X and Y and stuff like that, and you could try figuring out stuff, but let's just plot it out. And so when we plot this, anyone have a guess what this plot could possibly be? You're all wrong, it's a dinosaur, okay? So what's really interesting though, is like, okay, like that's kind of cool, right? It's a dinosaur plot, right? But what's interesting is that this is, this data set turns out to have, you can create the, there's a paper done here and I'll show it to you in a second, but there's a GIF right here of it changing over. Basically these data sets are showing the mean, the median, oh, it's the mean for X, the mean for Y, the standard deviation for X, standard deviation for Y, the correlation. And you can see here they're all very similar except for these like last decimal places. And they actually found a method to design any data set they want, whatever it looks like. And you can see that all of these have very different patterns. Like obviously, a dinosaur looks very different from like a bunch of random noise, different from, you know, a circle and all these things. And so this actually really emphasizes why visualization can be important, not just as an extra thing that you should do because, you know, your instructor said so, or because we said that we should do these kind of things. It is something that's a really important aspect. So it's kind of like the data source dozen, so kind of like the quartet. And you can see here the paper, it's linked on the bottom. But here's Ascom's quartet. And they basically figured out a way to construct all of these different, what's it called, different data set structures, basically, and still keep the mean, the median, the different statistics relatively close. And so this kind of shows you, again, like you have to visualize your data. Because the point is that all of these data sets, even though numerically they seem very similar, they are clearly different patterns. And we as humans, you know, obviously we can look at those patterns and we can immediately see those things. And so that's why it's always important to do your visualization. Okay. So that was kind of like the motivation of all of this. Any questions about anything? I could probably look at this for like hours, just watching these things go by. Any questions about like anything I kind of talked about, like visualization, why we do this, you know, why humans are good at it? Okay. Yeah, it's pretty basic, right? It's motivation. Hopefully I don't think anyone's like, oh, well, I wasn't going to do visualizations ever. I think people mostly figured out. So the next part is saying like, how do we use visualizations, right? Like, so the first thing is basically, it's like, okay, we know visualizations are important, but like, how do we use them and when do we use them? So the first thing is basically exploratory data, right? So this is when we're kind of exploring for yourself, do it for yourself, right? You're exploring the data and basically you're not trying to impress anyone. You're trying to find patterns for yourself. You're just trying to do some quick and dirty, you know, visualizations where you don't have to think about stuff and you just try it out and it works, right? So they don't have to be perfect. You're just looking for patterns, relationships. You're looking to things like, what does the data overall look like? And then say, okay, maybe this might give me a suggestion of how to explore it further. Or when you're exploring or find other patterns, you might recall back to your visualization and say, oh, this might be actually something that's important, okay? Another part you can think about is like you're connecting it to questions. Usually you'll ask a question like, well, like, you know, so I say like, what is the average price? Or like, do I expect the average to be different for different ages? And this is where you might actually do a visualization to kind of quickly see, is it worth exploring further, okay? And so exploratory, again, is for yourself, okay? But they don't have to be perfect. Usually there's ones with like I don't know about you all, but like when I was doing math, like back in high school, my math teacher would always say, and I had my same math teacher in high school for 3 different years, like for 3 different math courses, but like the same math teacher for 3 different years. And she would always say, which I think every math teacher says, like label your axes, right? Always label your axes. And this kind of stuff, you probably don't have to label your axes because you are just doing a quick exploration. Like it doesn't have to matter what it looks like. You're just trying to see what it looks like, okay? The next part really is what we probably think of data visualization is explanatory. And that's when you're doing it for someone else, okay? And basically you're giving a visualization to emphasize your message. Okay, and I think I've talked about this to a lot of people in presentations. When you're doing a presentation, you do a visualization. You're not doing visualizations that are like this, like exploratory. You're doing visualizations to highlight an insight or emphasize a point. You want someone to visually connect with that image and remember that kind of thing. Okay, so the things that you should make sure they're insightful, meaning that they actually give some information about your data set. They're accurate. So make sure, we'll talk about like how you can accidentally or on purposely lie with your visualization, and they should be visually appealing. So they shouldn't be so jarring, be like, oh, like it's so ugly, I don't want to look at it. For example, like a horrible pie chart. You don't want to have something that's going to throw off everyone. I kid, because obviously people love pie charts because they don't know any better. They haven't seen the light yet. But the more important part is that you want to make something interesting to someone so they can remember it and all that stuff. And again, highlight an insight. You're trying to make a narrative. You're trying to make a story. Okay, that's really your goal as a data scientist. And then this part right here I included simplify. So don't include it all necessarily. Sometimes it makes sense to emphasize your point. For example, one big thing I see a lot of times is people will put like a scatter plot and a line, like a regression line through your scatter plot. There's not a real reason unless the scatter plot actually has real information that would be useful to explain. So for example, maybe it's randomly distributed, or maybe, you know, there's a weird, like, you know, bulge like in part of the data. And even though you have your line going through, maybe it's an interesting point that you're going to talk about. But a big part of it is you just want to simplify it. So you say, just have the line there. Like you don't need the rest of the data points. Okay? And this is, it helps have people focus on your message, okay, and what you want to explain and communicate, all right? So we have a little like, when to use them. So we know the data science lifecycle. We have basically your extraction, like your data, you're collecting your data, you're cleaning your data, you're exploring the data, you're analyzing it, right? This could also be, kind of partly exploring, but also partly modeling, right? And then you're sharing the data, you're you're communicating that information. So this is where like the different visualizations would happen. So when you're cleaning data, you're probably using exploratory visuals, right? You're not doing anything for anyone. You're doing it for yourself to try to figure out what to clean up. Same thing for exploratory, right? You're doing exploratory visualizations, all right? So you're making things that are like help guide you to do actionable things on the data. When you're doing analyzing, this is when it can go either way. So when you're analyzing, this could be something more like, okay, I'm exploring and I found something interesting and I want to emphasize this like on a feature, some kind of feature, right? And that would be closer to what's called like when you're trying to emphasize some feature, you want to show this to someone else. That might be an explanatory, but it might also just be exploring, saying, well, maybe this is something interesting. Or if you're doing a model and you want to quickly see like, well, how well did the model do? You might do an exploratory thing. But if you really want to emphasize, oh, this model did really well, and you want to show this to someone else, you'd be doing some more explanatory. And then, of course, you're sharing it to someone else, whether that's to a data scientist, data analyst, another business stakeholder. Those are the things that would be, explanatory. Those are the things that you want to make sure are nice and clean and work really well. All right. So any questions on difference between explanatory versus exploratory visualizations? And it's very plain for a visualization talk right now, but just there'll be more visuals. Okay. So kind of quick quiz time. All right. So quick thing. So like imagine if you're going to do explanatory or exploratory. So I think the best way to do this, so you guys don't have to yell out all at once, we'll just do a little voting thing. So we'll say like 1 for explanatory or exploratory and 2 for explanatory. So 1 for explore, 2 for explain. Explore comes before explain. Hopefully that kind of makes sense. So this first one, plots are for stories. So these plots that are supposed to be used for stories. Is this explanatory or exploratory? So I see 2 or 1. So explore is 1, 2 is explain. And just keep it up so that way you can kind of go through. All right, 2, yeah, explanatory, right? So number 2. I know this is the best I can kind of think without you guys all shouting out. I guess you guys could shout out, but there's no guarantee. Okay, so hopefully this is pretty easy. Happens at the start of most analysis. Exploratory or explanatory? Oh, good. I see most people, Hazel's thinking. Just thinking, it's okay. Why not 1? Yeah, that's okay. All right, so I see 1, exploratory. You're right on that, right? So most of the time that happens at the very beginning because we're not trying to dive deep and make things all nice and pretty. We're making things like we're just diving deep and we're getting, into the dirty data. We're trying to figure things out. We're doing exploratory, okay? So usually at the end of the data science lifecycle. So kind of like the opposite of this. Okay. So remember 1's for exploratory, 2 is for explanatory. And I think I'm waiting for just Andrew, I can't tell. Maybe it's just too dark. All right, 2, yeah, explanatory. All right. See, isn't this fun? You guys all get 1,000 points so far. All right, and then let's hear, when making these plots, pay attention to, so when making these plots, we pay attention to making the plot insightful to your audience. So you're making it insightful. Yeah, I see, that's pretty obvious, explanatory. And then finding missing values in a data set for this analysis. Yeah, exploratory. All right, pretty straightforward. If you keep that in mind, just like when you should like put a lot of effort versus like not a lot of effort kind of deal. Well, not, I should say effort, that's not the wrong word. But basically when you're trying to make it like really nice and pretty and understandable, if you're doing an exploratory part, maybe you're taking too much time out of your thing and you can move on to something else. And so these kind of help guide you a little bit like when you should kind of practice this, okay? So I do have a little link here for Kaggle, which has Kaggle has a bunch of like learn stuff, which I found really useful. This right here, this kind of like little mini course kind of shows you a little bit between like univariate, bivariate. So a lot of these stuff you already have, styling, stuff like that. But if you look like for univariate, for example, univariate is basically just one variable. So you can hear like bar chart, line chart, and they kind of walk you through some aspects and stuff like this. So I find it a really useful like a little quick, like I would say like this would be a good like review thing. Like you're like, okay, like I want to get some data visualization. You probably have some skills already with it. It kind of can help you a little bit see like what are things. One thing you probably haven't seen too much with the bivariates, for example, hex plots, different line charts. We haven't done too much of like data stuff like this, but for example, like line charts, which we haven't done a lot of, it's much more for data that changes over time, or some kind of like we call like seasonality or something where basically there's changes over some other variable. So usually a time series and stuff like this. Stacked bar chart, I think I've mentioned about this a few before, but stacked bar charts are really useful for, we'll talk about when they're really useful, but basically they're useful when you're looking at multiple, like not multiple, but two different kind of variables, like how it can change. So the classic one is usually scatter plot. This is usually go-to. And then you might consider these other ones, depending if you want to make more explanatory, or maybe it makes more sense to explain these parts. So I'm not going to go through this because it shows all the code and stuff here, and it kind of goes through a little bit like why you would use these. So I think it's a really great tutorial. So I'm just going to point to you guys in that direction. And then just know to kind of talk about a little bit what you can do. And Seaborn is super common. But I did want to mention about multivariate. So this is kind of like, these are like the really intense visuals. And this is where people kind of get like really creative. And sometimes though, I think the visuals get a little too out of hand, where people try to make it different and unusual, that it's not super useful. But box plots are a big one. I think most people kind of forget that exist, and they can be super useful because they can give a distribution. My other part of like box plots are like violin plots, which we'll see a little bit later, hopefully. But violin plots also supported in Seaborn, which show the distribution, which can be super useful. Okay, but box plots are old school. So if you're ever doing like analysis to another people who have some analysis background, box plots are a good go-to. All right. So any questions on, I don't know, explanatory, exploratory, when to look at this stuff? Thumbs up, thumbs down for understanding. Cool. All right. Cool. And it's not too much code right now, so this is good. All right, so this is my favorite. Oh, shield your eyes, don't look at that. Okay, so now we're gonna talk about good visualizations. And visualization, I call it visualization DNA, like what makes visualizations, right? And so the parts of visualization basically, and I think the curriculum actually talks about this in section 6, is about like what parts of visualizations actually matter. And obviously it has to be visual, right? Obviously this is might be an issue for accessibility if someone is like blind doing visualizations. There's some interesting things that people have done in the past. I'll just say like a little quick aside that's not related to this topic, but I think it's really cool. There was a blind astrophysicist, and she was looking at, I believe, I want to say it was gamma ray burst, but maybe I'm wrong. I think it was might have been star brightness. But she was looking at this stuff, and she was blind, and so a lot of stuff's like, well, how do you visualize this? She actually made audio, made audio of the visuals based on pitch and stuff like this. So obviously your medium just depends on what you can visualize. But it turns out these are a few things. Oops, sorry. Position, length, and size, which are kind of related but a little different. Shape, color, angle, which we'll talk about. Don't use these because angle turns out to be really bad. But there's other things too. For example, motion, you know, can be another thing if you have like an interactive plot. That can be something that's useful. Different shapes too, varied shapes can be useful. So the curriculum kind of talks about a little bit, but I'm going to go a little bit detailed for some of these aspects. So the main ones I'm going to point out is length and size and position. All right. So the first one is position. Is basically we're really good at figuring out when things are different locations, which sounds really like you're going to like hear me say some of these stuff and you're going to be like, this sounds really dumb, Victor. Like, of course we know the difference between where it's here or over here, but it turns out positions actually, based on the research, we find that people are really good at seeing the slight differences in position. So main thing is scatter plot. Also line plots, okay? But scatter plots are a big one where it's just position, okay? The next one is length and size. So this is actually a little bit different. So length obviously is like how tall it is, or how, you know, if it's a horizontal, how far off to the left it is. Size is a little bit different because size can also mean area. And this is where I'm going to put a little caveat we'll talk about in a second, is that be careful about area, because we'll talk about that area is actually not a great way of people comparing things, and we'll talk about that a little bit later. But for relative size, you can see here, like this plot earlier, our bar charts, when they're stuck together like this, you can see very clearly one's much taller. You can see very quickly which one's over here. Stacked bar charts, bar plots, yeah. we can actually see here is that we can see the overall shape of these bars. We can see, okay, clearly this is more. Again, I don't even have to look at like what this is. Like this is US gun manufacturing, right? Guns made. But like the point is like I don't really have to look at it very quickly. I can very quickly see what are the big spots, what are the low points. I can see here that red in general tends to be much bigger, but maybe this blue here, for example, was a lot harder. So you can kind of see like a little bit of pattern here, and you can very quickly kind of notice. So if I look back, it's like, okay, this blue seems to be like the second biggest, red is the biggest. Okay, you see reds with the rifles. I think like pistols might have increased, in these past couple years, but revolvers have always been kind of relatively small. Shotguns look like, if I look really quickly, look more or less about the same. There's some fluctuation, but not a huge amount, right? So this is where we can use stacked bar charts to help us kind of like see that difference in like size. Okay, and then scatter plots, I'm sorry, on length, but also size. And scatter plots, we can also include size in here. So this is actually from Seaborn too, and I'll link that later. But basically that this right here is emphasizing, like the different, like you can actually use size within your scatter plot. I would say be careful with this one, and I'll mention about a little bit why. Because if the sizes are very drastic or they're all very similar and you're using size on that way, it can be kind of misleading or kind of hard to understand. Also know that this scatter plot is helping you with also color. So the color and the size helps kind of emphasize, which ones are large and which ones which ones are larger and which ones are smaller. Okay, so that's length and size. Next one is shape. Okay, so shape basically can help distinguish different points. Usually we talk about this in like scatter plots. Now, be very careful with shapes. One thing you want to do with shapes is that you only want to represent quantitative data with shapes. I'm not quantitative, sorry, categorical data. I don't know why I said quantitative. You want to rate categorical data with shapes because that actually gives what it means, right? Be very careful. Sometimes if you ever make a plot and you're like, man, there's a lot of shapes in this part, realize that you might be using numerical data, okay? So, but this is a good emphasis. You can see groups. And again, here they kind of use color as well to emphasize this. I personally probably would have only picked one of these two. In this case, crosses and pluses might actually be too similar. I usually would use different shapes, maybe at most like 2 or 3, like a circle and a square. I used to see circles, squares, and triangles. But past that point, if you have like 10 different shapes, it's going to be difficult to actually figure things out. And then maybe might mean you have to simplify it or try something else to visualize. Okay. Last one is color. Well, not last one, but second to last one. Color. Again, you're doing something to emphasize, like you can use it to emphasize your findings or say these are distinct parts. So for example, lunch versus dinner here. Again, I don't even know what this data is. I pulled this off from, I think, Seaborn. But the point here is that you can use color to distinguish different aspects, okay? One thing that I say is that I just grabbed a quick example here, but the default for bar charts is they'll use color. And this is actually where this is not necessary on here. And I would actually say I wouldn't use this color like this for blue, orange, green, red for Thursday, Friday, Saturday, Sunday. Does anyone have an idea like why this, it's not necessarily bad, but like why it's not necessary in this case?
It doesn't really tell you any more information. It just makes it busier.
Yeah, thank you, Andrew. It makes it busier. It re-emphasizes the same thing that you already see. Giovanna, were you going to say the same thing?
Yeah, I was going to say implies there's more information to it than
yes,
there
that's
is.
that is perfect. I like that you said it implies, because the color might make it seem like there's some other emphasis. And this is where the research actually is really interesting, is that people are drawn towards certain colors more than others. And this is where you might accidentally encourage your viewer to, like your audience to focus on the visualization, like the red color more than something that's more neutral. And this is where it can kind of be a little like, ooh, like be careful with adding extra elements that aren't necessary, okay? Really, we'll talk about like what you can do, but really like if you have a bar chart that doesn't have any, like if you have the categories already here, you should just keep it, basically like one simple color. And that's the emphasis. If there is a reason to have a color, maybe that might be something useful, but always be careful. So that's why I say sometimes for bar charts. Okay, and now I get to crack my fingers. My favorite one, angles. We can detect angles. For example, we can tell if something's like this versus like this. However, don't do this. And we'll talk about it. Research has shown us. So pie charts, I just picked an ugly pie chart. They weren't hard to find, but you can see here is that this pie chart just has a lot going on to it, especially as we get like in these, like clearly like these smaller parts, it's getting kind of ridiculous. And you can see here, like these parts right here, you're kind of like, it's like, okay, these are about the same size, but can you tell me honestly, like without looking at the numbers, how much bigger this one is to like this blue one right here, hardware? And you can tell it's smaller, but it's like, I don't know how much smaller. Or what about between hardware and entertainment, this blue and orange one? These two also, I couldn't necessarily, if that number wasn't there, I might actually think that the blue one's smaller. And this is where someone actually took pie charts, like, oh, if I took a pie chart that's really bad and try to make it better, so they put numbers on it, they ordered it from biggest to smallest over here, they labeled each part. My philosophy on visualizations is that if you have to emphasize every single point of your data visualization, where basically it's just a bunch of numbers and labels, it's no longer a visualization. It's now like basically just a thing of text. So this is it kind of emphasizing why these are really bad. Which brings me to donut charts. Oh, I'm just loving today right now because I just get to say why I dislike these things. Donut charts, I've heard people say, well, okay, pie charts are bad, but donut charts are much better. If you look at this, you'll see that this is literally a pie chart, but it's like this, to make it, if you haven't seen a donut chart, this outside ring is the donut chart. This is a pie chart, okay? You can see they're essentially the same thing. The problem with this is that it might be kind of better in the sense that like pie charts I can go on and on, but pie charts kind of emphasizes, the thing that you're looking here, like in a pie chart, is like, oh, it's supposed to be about angle. That's how much the pie chart is. However, it's also area, but people don't do very good with area or, what's it called? What's it, angle? And this one would almost be like, hey, this is basically like looking at area. Like, this is the longer length. It's a little bit easier. However, in this case, it might be easier just to make a stacked bar chart. So again, donut charts are just pie charts in disguise. Don't be tricked by them. People will try to trick you and say, oh, when I say trick, it's like people like donut charts, like, oh, donut charts. And it's really like modern right now where everyone's using donut charts. And it's just, they're just pie charts, everyone. Like, that's all they are. So anyway, don't use these. And then the next one is just like, just a whole new kind of just craziness, which it's just like, if this pie charts would almost be like, okay, in the sense that you're using area, if we were better at doing area, but it's mostly focused on angle. That's what we find in research. Racetrack charts, which I'm glad that it took me a while to find like a good visualization of racetrack charts, which means they're not super common. They're really useful, or not really used in infographics. I think because they look pretty. But this is purely on now, what's it called? This is purely now, what's it called? Angle. And this is the problem, as you can see, is that this hair care and then this orange one, so this kind of pinkish one, reddish one, and this orange one are basically off by just 1%. But this is the first part, is that the yellow and the green one are the same value. However, if you quickly look at this, your tendency will be to say, oh, the green one must be bigger because it's longer. It's got more area. That's what we tend to see first. So racetrack charts are also just, it took the bad parts of pie charts and somehow made it slightly worse, but somehow tried to make it more visually appealing. So again, don't use these things. Just, I don't know. I can't emphasize that enough. We'll talk about a little bit later when you might use a pie chart. But the reason why I kind of emphasize this is that basically researchers have actually done this and seen like what works well with visualization. And so researchers found that positional changes, length changes, those things in particular are very good at, or we're very good at detecting those changes. So if we see something move from here to here, we know that's a change. Length changes, if we know something like comparing the lengths, we can do that very quickly and easily and understanding of those parts. I would throw in like motion in there too. We're pretty good at like detecting like when motions are significant. However, I would say that that probably makes it more difficult for you to like really emphasize to the point where it might be distracting. So I tend to say 2D plots with basically no motion can be really useful. Okay, we're bad at understanding, as you guys probably read this already, is color hues. So what I mean by that is like when you go from a full rainbow spectrum, what is like, for example, this has got too much going bad for it right now, but let's just say like ignoring like the size of it, is that going from pink to like green, is that like a number, like what is that value change? Like if I go from slightly green to more green, we don't have a good like we can code it and say, okay, this is the change, but we don't understand like, well, how much more green is that? Going from this green to slightly more green, and then saying going from all the way to like red, you know, which is also bad, but like going from like this red to this much red, we have a hard time understanding what that changes. So hue changes are not really great. And then area changes, angles, don't use pie charts. Like just bad deals. Area is a bad one too. We have a real hard time understanding when it's not just the actual length, we're actually talking about the full area, and that's really hard. And also angles kind of get thrown in there. Okay. Any questions on any of these parts? Angles. Oh, go and close this. It's making me, it's disturbing me a lot. I just think about all the people who are using pie charts. They shouldn't. But position, length, and time. Position and length and size, those are probably the main ones. I would say color to emphasize category. Those would probably be the main three parts. Okay, so I kind of showed you a little bit like what the different DNA is. I have already started talking about like what makes things bad. But one way we can talk about making good visualizations is basically saying, talk about what makes a bad visualization. Okay, so the bad visualizations, it's easier to just like spot like these bad statistics. Like it's easier to, like I misspoke this, it should just be visualizations, but like it's easier to see the bad stuff, right? So when we see something, we're like, okay, just don't do this. So when we do a bad visualization, at best, they obscure what we're trying to do, and at worst, they actually lie to us. So at the best, you like did something that's not as clear. You could have done it another way to make it more clear and accurate. At the other end of the spectrum, you can purposely try to lie to people about with stuff, which people have either purposely or not purposely, right? So first thing is like basically just misleading. So this is actually an interesting one. I don't think it's talked, oh no, is it not here? Where'd you go? Wait, I'm sorry guys. No, okay. I'm gonna look it up real quick. So, okay, because I think this was a really interesting. So this one's a really interesting misleading one that is done over and over again. And I'm trying to, here's one. Okay. So I'm gonna open this, open this image, a new tab. So this one right here is a typical path of a hurricane, like how it's presented. And you'll see at the very top, first of all, there's a lot of stuff going on here, but let's focus on this center part. But at the very top, you can see the cone contains the probable path of the storm center, but does not show the size of the storm. Hazardous conditions can occur outside the cone. So this is actually designed for people who are in meteorological, like meteorologists, right? So like weather people. Okay, and so they understand that what this is supposed to mean. The problem with this is that if you look at this first, what's your first instinct? Like if you looked at this visual of this hurricane, like if I took like, oh, let me just ask, what's your first instinct, I guess? Do you know what I think it's like?
We think the storm is getting bigger.
Yeah, it looks like it's getting bigger. It starts off really small, right? And it gets bigger, and look, by the time it gets over here, oh shoot, hurricane's all over the place, right? That is probably your initial reaction, and that is what most people kind of react when they see these kind of things. This also can be really dangerous in that sense, is that if you think about this, if you know about hurricanes, they have the eye of the storm, and what they're talking about is where the eye of the storm is being tracked. Like, where is the probability? And this is basically a confidence interval. And so the thing is that the hurricane could technically be going, the most probability is going right down the middle, but it could possibly go off and the middle goes here. Well, the eye of the storm will go here. That means the hurricane's passing over. So the problem is if you see this visualization and you're like over on the edge right here, like in Virginia, right? You might say, hey, like, okay, like not a big deal. The hurricane's kind of off the side. I'll get like the barely part of it. But that's not what it means. It actually means that the storm could go right here, but you could actually be in the middle of the storm. And this is actually, there's a visual like this for Hurricane Katrina. And people have talked about that this kind of image was presented to a lot of people just like on the news, say, oh, like this is the hurricane. And the problem is that people wondered, I think there's still some research being done, is that if people perceive that as, oh, I'm outside of the storm or I'm just on the edge of the storm, it's not going to be a big deal. And so this is an ongoing kind of debate of like when you give a visual, which could be perfectly good for a meteorologist, right? But for the average person who's not versed in these things, it could be really, really bad news for them. And you can see here you can see there's been issue because they put specifically on the top here, this cone does not represent like the hazardous conditions, does not represent the size of the storm. They had to put this up here because people look at this. But again, if you're putting words on your visualization to emphasize some point, it might not do very well. And that's why they have this. So this can be really misleading. Okay, so I just wanted to put that there. Okay, look at that. Okay, so misleading. Okay, so they can be misleading. Other things they can do is they can hide data. So here is data trying to hide behind a tree. And you can see it's not doing a great job. So sometimes you can actually hide this data. And am I realizing, sorry, I had other parts in here and I'm concerned that I'm missing parts. But basically know that sometimes you can accidentally hide data if you have too much going on, if you have a distraction, like it can basically push away everything that's going on. So I had some visualizations in here and I'm concerned I got rid of them, but just know that basically you can hide data, you can distract from people, and you can mislead. There's the like kind of the Bible on bad statistics is How to Lie with Statistics. Has anyone heard of this book before? This is kind of like, if you were to say one book that you should go read to understand visualization, and like honestly as a data scientist, this is the book to go for. In fact, it's a PDF right here. You can actually get that and read that through. So definitely interesting. It's a really good book to actually go through. Okay. All right. So things to specifically look out for. So I'm just realizing that. Okay. So these are bad visualization parts that you shouldn't do. So for one thing, it's called chart junk. And so chart junk is basically anything that is distracting from the rest of the actual part. And so this includes 3D graphs. 3D graphs, why does that have to be 3D? There's not usually a real reason to say it's a 3D graph, okay? You can see here basically some examples of like all this extra stuff. You can see these extra lines, even extra colors sometimes, which this could arguably be all right to like understand. But like when you have too much stuff, if you have too many numbers, like if you have numbers emphasizing each point, like for example, this is really common. I know it's kind of hard to see, but like you can see like these numbers right on top. Why do you need those numbers? Those numbers already exist. You should either have the numbers there or don't have them at all. You need to decide which two. They don't need to be too much because it distracts too much. One thing, Edward Tufte, who's a really famous person who came up with this, is the data ink ratio. Is that how much is your data represented on the ink versus how much everything else? If you have too many colors, you have weird images. Like I see a lot of like infographics do this where they use like some kind of image to like on top of their graph and do stuff like this. It doesn't really emphasize any point. It looks kind of cool, but like there's not a real reason to have this. Oh, I actually just noticed this one too. This one's like a triangle. It's got so much going on. This is a 3D graph with a triangle, which again is like, why does it have to be a pyramid? Like it doesn't, there's no emphasis on this. It could have just been a bar. And then they also made it 3-dimensional, which just adds whole new layers of like, I can't, like, even if it was bigger, it's like, what is this supposed to mean? It can give a lot of weird stuff to it. So things to look out for, heavy grid lines. If you have super heavy grid lines, it probably isn't necessary. Unnecessary text, basically too much information on top of your visualization. Pictures, like I said, shading or 3D components, don't have 3D components. And then ornamented chart axes, basically anything with a chart axis that it's just like having like extra information or possibly even numbers sometimes can be too much. If you label every single point, that might be not good, all right? So that's what chart junk is. Let's see here. I wish I could find this example. Back in the day, well, not back in the day, it's not that long ago, but like when I was doing a graduate course on advanced data visualization, I remember we had the first assignment and we had to make an assignment to like say, make this visualization. I don't even know what the data was, but I made this thing where I literally had like, I had colors representing one thing. They were circles and they were size dependent on some value and they moved. They were like a moving thing and I thought it was so cool. And like the movement, the speed at which they moved dictated also another part of their aspect. And I had the like number, like with the labels on top of the actual thing. And I was trying to put all this information on one visual and it was just a mess. And I'm just, I kind of wish I could have it, but I'm also kind of glad it doesn't exist. I can't kind of show that like, tied to me because it's a really bad like chart junk kind of like deal. It was too much information. So one thing to relieve chart junk is simplify or make another visualization. If you need to put more information on it, make a separate visualization to emphasize your point. Okay, so that's chart junk. Any questions on chart junk? Pretty good. Cool. All right. So next part is the misleading, which, oh, is this where? Oh, that's where I put it. Okay, I got distracted. Okay, there's my little visualization, and you can see the hurricane going on here. So you can see here is that the emphasis right here would be that it's the size of this hurricane. And what's crazy is I found this from a news site. Like this is actually reporting about this hurricane. And again, it's just, the problem is, I mean, it's debatable. Is it information that is useful? Yes. Is it information that can be misleading? Probably. Like this might be for most people when they first see this, they're not going to read all these things. They're going to see this thing and say, oh, there's the hurricane. Okay, so that's something to look out for. There's a little link right here, that's a great article on how to spot visualization lies. You can kind of see like when truncated axes, so like if the axis kind of squished down, I'll show an example of that later. Dual axes, don't use dual axes unless they're actually useful. In fact, I would probably say never use dual axes. You should really have two different charts. Basically, this chart, this line right here is emphasizing one number, while this one emphasizes another number. I usually do this for like, because it's similar but not the same. So just kind of be aware of that. This kind of talks about in the curriculum, numbers that don't add up, percentages, and you can start seeing like, you know, some examples. So I'll let you kind of go through this a little bit. Again, area, when area is defined, like if it's area by one dimension, that just basically means length. So anything with area can be really kind of, can really mess things up, either mislead someone or purposely lie to them. Okay, and then we'll talk about this one, 3D pie charts. Just make me shudder. There's, at least it's not colored, right? Like, I don't know, maybe that's a little bit better. Okay, so one aspect is called the lie factor. Looking this up, basically this lie factor is basically saying what the data is actually emphasizing and what you are actually representing. So the thing here is, without kind of going to full detail, is that looking at this doctor, it's supposed to represent, like, you know, the shrinking family doctor, right? This is a famous image if you search for it. This image, let me ask you guys, what's the thing that you think the doctor, the size of the doctor or whatever the doctor is doing, what is emphasizing the number? And whatever, like, what aspect of the doctor is representing this 27%, 16%, 12%? And, you know, just take a guess, like, I mean, just whatever you think or what you think it should be or what it is. So let me ask you then this. Oh,
like
go ahead.
The number of doctors per capita or something like that?
Yes, number of capita. Like that's like some number, right? But what's like the actual image? Like there's some aspect. So let me ask it a little differently. Is the size of the doctor, meaning like how, like area wise, is that what's representing the number, or is it how tall the doctor is? And that's the confusion part, right? Sorry, Andrew, it looks like you want to say something.
Size, I'd say.
I'm sorry? I think you kind of, I don't know, I couldn't hear you well.
Size?
Size, yeah, it's probably area. Like, and that's honestly what most people would look at, is like how big the doctor is, right? Not versus how tall it is. Because it's not like a bar chart where a bar is like equal width. It seems like it's growing and shrinking. And so this is where it can be really confusing and actually emphasize the parts. Another part of like the lie factor, this is a really famous one, is when George W. Bush was presenting about, when he was president, talking about tax cuts. And they were saying they were going to expire and they go to Obama's era. And what's interesting, it's kind of like they were saying, well, what it is right now and what it is right here. And it's kind of a small picture. We can kind of see like, oh, it's very small. But if you look carefully, it starts at 34. So the thing is, like, going from 34 or 35% to about 39.6% is a relatively small change. It's still a change. So that might be something that might be emphasized. But this might be saying, well, okay, what's the right way to do this? And knowing that, you know, whether it's done on purpose or whether it was purposeful or not. Okay. Oh, sorry, I saw Andrew's message about pie charts. I'll have to look at that later. Basically, like, knowing that, like, you know, what you're obscuring and stuff like this, and this can be kind of part. So like, this is a really famous one that people argue about all the time, about like, what is the real emphasis? And there can also be motivation for like why someone might want to do this or not do this. Okay. All right, so that's our life factor. Just know that this is an actual number you can calculate, saying what are you trying to represent versus what you actually are representing. Okay. All right. Last part of this on this for misleading. Oops, sorry guys. Misleading is 3D effects. So I kind of mentioned 3D TVs didn't take off. So it's time to kill 3D visualizations because they're not important. So this is one of my favorite ones because Apple had this, I don't remember what years, obviously Steve Jobs was still alive. But when they presented this, this is a real visualization they had. They had a 3D visualization. And you can see very quickly, if you look at the numbers and ignore the pie chart, 39%, 19%, 21%, and smaller percents. And you can see here, Apple here is in green. Now what's really interesting about this is that if you ignore the percents, and people have actually kind of like edited this out to kind of show you, is that if you look at this 19.5% and this 21%, if you kind of do a quick glance, it definitely looks like green is a little bit bigger, right? Like, I don't know about you guys, but like it definitely kind of sticks out a little bit, and people actually like kind of gotten rid of the numbers to can you figure it out? And it definitely comes out, and part of the reason why is this very subtle thing that they did is a 3D graph, and you can see here the 3D dimension here. And that's because, as you might know in your real world, is that things that are closer to you look much bigger versus when things are really far away from you look much smaller. And so the thing is that because that slice is slightly closer to you, the size of that now emphasizes, because it's 3D, it's like, oh, well, this looks bigger because it's 3D. Well, this doesn't really help you in this case. People kind of said, is Apple trying to pull a fast one on people and say, oh, look how much we've grown. Like, and this is where, you can say maybe it was an accident, maybe it was on purpose, But the point is here is that pie charts are awful and you shouldn't use 3D. Okay. So again, reasons why you can do that. But this is a really famous one. You can probably look this up too. All right. So that kind of gets into misleading. This leads into me one part for visualizations before I start bashing on a lot on pie charts or even more, is color. So color is really interesting. A few tips to using color. Okay. And this is not less and less misleading, but more like making good visualizations is a good thing to do is like start black and white. Like get rid of all color and see if the visualization by itself stands to the reason. If you need color to emphasize points, then you start adding color. But a good thing to start is actually without color. Unfortunately, the default for like Pandas and Seaborn, I believe, is to make bar charts, for example, all different colors. And so you have to kind of emphasize that point. But a good thing to start is no color, okay? Then make sure you use less intense colors. Don't use things that are like bright yellow and neon and stuff like that. It's just too intense for people, and people won't like really pay attention to it in that sense that like people forget about it, and it's just jarring. Okay, and the next thing is to communicate with color. So one thing you can do to communicate with color is to basically highlight interesting groups. So here, for example, this dark blue is emphasizing look at 1971. This is what I'm going to be talking about for whatever they're looking at or talking about. They want you to emphasize this point. You can also use this to highlight your message. Say, look at this part, maybe there's some reason why you want to do this part. Interesting groups too, like with a stacked bar chart or bar charts that are close together. You can use that to emphasize saying, okay, look at these different parts. That's why I'm using the color to emphasize the different groups and stuff. Okay, and just don't add color for the sake of adding color. If you don't need color, don't use it. Basically, you start off with black and white. Okay. Any questions on tips for using color? Cool. All right. One last thing I want to talk about is color blindness on color. Is that I don't know if is anyone here colorblind by chance? No. Okay. So if you are colorblind, red-green colorblindness is pretty common, especially in men. But basically, this is a simulation of like what red-green color blindness will look like. Basically, it's a lot harder to tell what's red and green. Never use red and green on top of each other, which again, we use red and green traffic lights. I still understand how we're able to do this. But as a visualization, you shouldn't use this. In fact, it's better to use orange to blue scale. Tableau, which is a data visualization tool, kind of shows this a lot of ways, and a lot of palettes now actually exist where you can use colors that actually are more color blind friendly in this. And so this blue, this orange, this gray, and these are a lot easier to distinguish as a simulated what it would look like. And I would emphasize using these kind of things versus using what's it called, like a red, green, and stuff like this. This is just, I don't know. I think at this point it's like you just should never put red and green anymore. And plus, we don't really, it's hard to tell, is this more green versus red, blue? It just makes it easier. So you'll see a lot more now using actually blue and orange. Okay. So that is color. That leads me, I know kind of over time, Are you guys okay if I kind of go a little bit longer so I can talk badly about some pie charts? If you have to go, it's okay. But I'll go ahead and just quick 5 minutes then. Pie charts, if I haven't heard already, they're bad. You should not use pie charts. There's actually a great little video playlist I put right here that just came out this week on data analysis, like no coding, just kind of like quickly going through. It's a really interesting playlist. But they had this video here, and I was just like, oh, cool, like this is perfect because, and there's a good minute like right here on this video when they talk about it on Computer File, I think it's the channel's name. They actually talk about like why pie charts are really bad, and basically it's like a good minute thing. You just shouldn't use them. Like the only time you should use them is because they look pretty. And that's pretty much true, is that the only time you could possibly use a pie chart / donut chart is basically when the data, not the data, when you have like maybe at most 3 different groups and they're significantly different from each other. But in that case, that's the only kind of use case. And other than that, it's kind of like, well, maybe you shouldn't use a pie chart then. So here's some code example. For example, I have here, I just made some data. This is from the visualization I showed in the very beginning. You can see here, it's probably better to like put the emphasis on like the axes, but there's a quick like exploratory part, right? So this right here, you can very quickly see, it's like, okay, I can see how big things are if you compare to each other. Now here, you can see that clearly the frontal lobe is larger, but then the rest of these, it's not super clear which one's bigger and by how much. And this is to emphasize, even with 4 different little, what's it called? Little slices, it's still difficult. And even if I arrange this so we went from like big to small in a very obvious way, I essentially have to put in the numbers to emphasize that which one's actually bigger. Versus you can look at this very quickly and you know immediately it's big or small versus this stuff. So there's some alternatives to pie charts. The main alternative I would say is a stacked bar chart. It's a simple alternative to most things. And you can see here, there's a whole, this website's Storytelling with Data is excellent, by the way, if you just want to go through this stuff. But they kind of talk about like how to do comparisons, what things you can do instead of a pie chart. Some of these are a little interesting. I'm not a huge fan of slope charts. I think they're a little harder to understand for most people. And they're not really necessarily, they're talking about like if you're comparing 2 pie charts. Like forget 1 pie chart, but comparing 2 pie charts is even harder because without the numbers, it's hard to tell which thing's next because you can't compare them next to each other. So this is where bar charts make a lot of sense, or stacked bar charts like this. Okay, I don't think there's a last one. No. Okay, so these are kind of like, I would say between these 2, replace pie charts with this. Unfortunately, people love pie charts for some reason. They just look pretty. I don't know if you guys can hear this audio. Can you guys hear that? No. So good. So here's that awful here's that awful donut pie chart and everything like that. But basically he was saying like, you know, you could go, oh, I think they just showed it right there. But he shows like, he's like, look, you can do a pie chart or a bar chart. It's like, but some people do a pie chart, and he says pretty much, don't use pie charts. Like it's just never a good idea. Okay. So anyway, that's a really interesting video. I have it linked in there. There's also a new series, which you guys all could probably watch through now and understand it all too well. No, they code in R, so it's not Python like we used to, but the same concepts apply, and it's a pretty useful thing. All right, so that kind of ends everything that I wanted to talk about. Any last questions or concerns? I know Andrew showed this. Was it bad? Was it the worst chart in the world? Yes. Oh, yes. Okay. And you can see here comparing pie charts. Just awful. Thank you, Andrew, for sharing this. And you can see here the same data. Look at this data. I'm sorry, I'm getting a little excited, but like this pie chart is awful. You know, trying to compare it. And then look at this. You can immediately see the pattern. You can see what things are compared to. Why not just do this? This just makes sense. And I'll tell you why. Because, I don't know, whoever's in charge, whoever has like a stake in pie charts has been pushing the agenda of like saying you should use pie charts because they look pretty and stuff like this. But this is beautiful because it's accurate and it's easy to understand. And anyone can look at this. A 5-year-old can understand and know which one's taller. A 5-year-old is not gonna look at this. A 30-year-old, a 50-year-old might not be able to look at this and be able to tell immediately because our brains just aren't designed to understand those parts. Okay, so that kind of ends everything. Again, any questions? Okay, and now you should all raise your right hand and say, I promise I will never use pie charts, right? You can do it in your heart, okay. All right, I'll go ahead and stop recording now, and I can let you guys go. Oh, can I stop recording?